Sorry for joining late. Can you guys hear me?
Yes, sir. I can hear you. Good evening, sir.
Good evening. How are you doing?
Yes, boss. Good evening, sir.
Yeah, how was your day now?
Ah, man.
Feeling alright, sir?
Hectic, but I can't complain.
Okay. Sam, how about you? Because like see you are the flexing one.
I day just there.
Okay. Did you guys see the assignment I dropped on
Yes,
the
sir. We
class?
saw it. Saw them.
Okay, any questions? I think we'll start from taking questions on that. Because it's going to form a part of your grading the 30%. So please put in your best. But yeah, any
When are
questions?
when are we submitting it? Or and
So
again,
what I
can
sent
we
deadline like 23rd. So it's like 23rd of this
can
month.
we use just JavaScript because TypeScript is still giving me challenges to do now. I use
Yeah, you can
JavaScript.
use, like I said, you can use that JavaScript or TypeScript.
Okay, okay. I wrote mine in pure JavaScript functions.
Okay, no problem. But if you can try TypeScript, additional points for that, but it's not compulsory. Like I said, just put in, just write what you know how to write best. As long as the code runs, it's fine. Yeah. So last class, we started the basic structures of TypeScript, JavaScript, combining them side by side and all. We stopped at functions in the last class. So today's class will be continuing from there. I'll share my screen shortly. Dun, 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 dun. Okay, so can anyone so I want you guys to give a recap of the last class. So Samuel, let's go first. Samuel, are you there?
Yes, I'm with you. I'm just trying to reiterate what we did last time. Trying to remember. No, we did more of TypeScript where we talk about data types. That like unlike vanilla JavaScript that is not strict in data typing. TypeScript is always strict in data typing. For you to declare any data type, you must indicate whether it's a number or a string or a boolean or an array or object. Then from there we'll talk about control flows where we wrote for loop, while loop, and do while loop. Then we also talk about conditional statements when we use if statement to check if static conditions were met in our control flows. And what else did we do? I think that was basically all we did last class. Thank you.
Okay. We also actually touched on functions. Um, but yeah, Brighton, how about you?
Yeah, it was in the function we did all those conditional statements.
Yeah, but and then we broke down what's the structure of a function, parameter, name, and
Yes,
then
yes,
function, all of that. Yeah.
that's true.
Okay, Brighton, anything to add?
So, what was the question? Is this structure of a for loop?
No, just recap of our last class.
Okay, so we did the syntax for TypeScript and Java that it is static type. Like you have to define the data type of if you want to declare a variable, and then we then went into the data types in strings, objects. You have numbers. That one. Yeah, I think those are the then talk of big init and the rest. Then after that we did flow statement. So for loop do why loop. Then talk about break that breaks out of a loop. Then continue. then continue like skip the iteration, then but keeps the loop running. Then after that, we talk of a like a compressed loop where you say for C in this, but it's usually for arrays. That's when you use that. Instead of using the for where you declare you have three statements in the for loop, you can just do a for. Call it an enhanced for loop also. Then we did flow state no yeah condition statement if else if and then if else, then switch. Also made mention of switch, switch case statement, and then the default, right? That one runs only when no condition was met. That's when the default runs. Then you made mention of functions. So we talked about synchronous and synchronous functions, and then yeah, we also talked about variables. So the variables, say we have the let, we have the var, and we have the na. So na, he said, is when you don't know the data type you want to put in. Right? Yes. Then you can use the na. Then let this let he said that it works more on a block. If you define two lets, but one is in a block and one is outside the block, the one that in the block will run like independently on its own, the one outside the block will run independently. But however, in the case of var, we want to override the outside var. We want to coerce. I don't know if that's the word. The var in the inner block. So,
Okay. Okay.
what they made mention of arrow functions.
Yeah.
I said arrow function is used in what again? I've forgotten.
Yeah, I thought arrow functions are functions basically without any name, right? You don't have a name. They're anonymous functions. Um, but yeah. Okay, that's good. That's good. That was a good recap of what we did in the last class. So today we'll be going into so we'll continue with functions. So we'll look at asynchronous functions, and yeah, we'll talk about promises and async functions. So then also we'll cover classes, which will probably take the most of our time, and then it will probably get to TypeScript interfaces. Okay, so let me share my other screen. So as usual, we would go back to our regular code. Okay, so in JavaScript, right, or TypeScript, remember that one of the advantages is because we want to write non-blocking code, right? And now because we want to write non-blocking code, the only way we can do that is by writing asynchronous functions, right? So asynchronous functions help us to write non-blocking code. Now in JavaScript and TypeScript, there is a way to write. There are two ways actually to write asynchronous function. There's a promise way, right? And there's the async, putting like an async keyword before your function. So here's an example, right? So I'm sure you're familiar with what we call like, I don't know if anybody knows what we call like. So if you are doing like a like, so if you had like a alarm clock, right? And maybe you want to snooze that alarm clock to a particular time, right? It's more like, oh, I want this alarm clock to go off, be in sleep mode until like 5 minutes later or 10 minutes later, right? So now we'll see an example around that very shortly. So we're going to start first with how to write asynchronous function using a promise, right? So let's look at this function first. So let's name it function sleep, right? So this is just passing a variable of how long I want this to sleep, right? and then this will return back. So to create a promise in JavaScript, we use the keyword promise, right? So new promise. Promise is actually a class in JavaScript. When we get to class, you understand how this was done. But promise is an inbuilt library class in JavaScript that allows us to create promise functions. Now, a promise has two parameters that it takes. So it has the resolve and the reject, right? So, but for this in this case, we are not looking at reject, just the resolve. Now, the difference between resolve and reject is that resolve tells you, oh, what you should do, like the success states basically of. So when my promise or whatever I'm writing is successful, I want to do X. If it's not successful, like an error is thrown, reject with and return this particular value. So that's what's happening here, right? So sorry, let me bring this back up. Yeah. So basically, you remember these are set timeout and stuff that we talked about the other day. So this is just like a JavaScript library function that would wait up to like a particular second, and then when it's done, this resolve will then be called. Now you can call resolve. So resolve is actually a function, right? So you can call it back with um, sleepover, right? So hold on. Um, so because we're using TypeScript here, we want to return back a promise that returns back a string, right? So let's try to fix this. Oh, okay, okay. I think I know what's going on here. So right now, so we have to rewrite this function. Can anyone tell me what's happening here? Um, so basically, right, the set timeout function returns back a void, like it doesn't return back anything basically in JavaScript. So I'm trying to do resolve, which is like my return statement, and I'm trying to return back a value, so it won't work here. So for me to rewrite this code now, I'll have to take this resolve outside the set timeout, right? So let's do it this way. So we'll have a function. So you can see this is also an arrow function, like I will explain to you. So arrow function allows us to, because right now I could have said function whatever, right? But arrow function allows us to easily like define a function and just pass in the parameters, right? So in order to call this now, I can't do a direct I have to manually like initiate the return. Also, another thing about arrow function, let me go back to where the code was before. So if you look at the way the code was before, right? I didn't have to like put inside the regular curly braces that we have for functions. And that's because I'm using an arrow function. So with an arrow function, you can point the arrows to like return back like whatever this result is, right? It will return it back immediately. You don't have to put it inside this curly braces for it to work. So that's another benefit of using arrow function. It makes your code to be much cleaner, right? But because I want to do something apart from just returning back a single line statement, I will have to put it inside the curly braces this time around, right? So we're going to do this, and then I'll have to explicitly say return, right? Or resolved in this case. So promises don't have return, they have resolved. So I could say I'm setting my timeout for um sorry, set timeout. So mm, I don't know. I'm trying to. I don't want to put any function inside the set timeout. It should just run on its own, right? Resolve. Okay, cool. Okay, so what we're doing here is that so enough for me to be able to like basically return back like a string rather than just like resolving that the promise is done, right? I had to write it like an actual function, right? Where I have the curly braces and all of that. So in this case now, you would see that this sleep function is now a promise, right? So in JavaScript or TypeScript, promises are also asynchronous functions, right? And you see why I said so. Now, if you want to execute this code or run this function in JavaScript or TypeScript, before now, right, you would then call the function, passing the variable, right, and then we use this keyword called then, right? So then says that okay, after the promise has run, do this next, right? Then it has the result of the promise, which is what we have here, right? And then if you you can also log the results. Also, you can catch errors. So remember I talked about that there are two parameters in the promise, the resolve and the reject, right? So whatever your reject is returning back, you can also catch that error here, right? And then obviously console log the error. So this was the way we users were handling like promises and asynchronous functions before some new standards came into play, right? Today some people still use this pattern, especially for some use cases where you can't just write a straight up async function, right? You want to like use a promise because you want to control when the promise will return back a result. Do you get? Or when the function return back, which is what I'm doing here. Like I'm basically controlling that. Okay, it's only when this timeout has elapsed, that is when I want you to return back a result, right? So promises are good for that kind of level of control, right? So if we run this now, you would see. So let's run our code. Sorry, last steps, yes. So you can see our code return back these results. I am done, right? Let's try and use the reject parameter so you can see what happens. So if we choose this error now, so in JavaScript or TypeScript, there's what we call the throw keyword. It allows us to throw errors, right? Or like, so if something is going to cause an error in your code, you can do that here, right? So you can insert the error class and then pass a message, right? Let me do something here. Let me remove this out first. Let me just call rejects. Let me call rejects. Also, I think let's pass a conditional variable here into the function. So we just say if rejects, then this will run. If not, this would run. Okay, so we have a conditional variable. So let's say this is true, right? And then if we run this again now, you will see that this time around it's going to be the error that will be logged, right? Not the result, because we are rejecting the promise call, right? So we'll see now. Can you see? So I am rejected error. So that's what is returned back, right? So in promises, like I said again, it allows you to be able to what they call it, to resolve or reject or return back a response that your promise. Okay, this is what I've executed, and this is the result. But it kind of gives us the flexibility in which we can determine when we want to return that result back, right? Especially when we are dealing with functions like set timeout, set interval, or whatever other function, right? So that's what promises are all about. And this is how you eventually call a promise function using the then keyword so you can get the return result of the promise function. And then the catch keywords to just catch any error that the promise throws. Any questions? I know this is like a lot, but any questions? Can you guys see me? Hello?
Yes, I can hear you.
Okay, any questions?
Honestly, I don't really understand this part.
Okay, where do you want me to start from again?
Like, I don't know if I'll be taking you so far from sleep.
Okay, so do you understand the need for promises? Let's start from there.
Yeah, you said like when something runs, then you say okay. After 5 minutes, then you come up.
It's always like this, so this is just a very simple example, right? But yeah, go ahead.
Like when it's like an interval, a set interval, time
Mm-hmm.
interval. I mean,
Mm-hmm.
when something you want an action to happen every 5 minutes, you then set up a promise. That's what I got.
Okay. Brighton, what about you?
It's Brighton speaking.
Oh, sorry.
Brighton is the one that spoke, rather.
Sorry, Brighton. I'm still trying to differentiate you guys' voice. I can't see my screen right now. Samuel.
Yeah, I'm with you, sir.
Yeah, so what do you understand by promise, or did you understand what I explained so far?
I lost my internet for let's say for the past 5 to 10 minutes, so I just
Oh,
reconnected.
wow. Oh. I didn't notice. Okay, so let's go back. Let's dive a little bit back. Remember, I came from the angle of that in TypeScript. One of the things that or JavaScript that makes it possible for us to like scale with the applications we write with JavaScript or TypeScript in Node.js is because we can write non-blocking code, right? Non-blocking code allows us to do stuff in the background while we do other things. Do you get now? And also we can wait on the results to come in, right, without blocking the code execution stack within the library or the framework, right? So I was saying now that promises are one way to write non-blocking functions or code in JavaScript. And I was trying to explain how to construct a promise in TypeScript or JavaScript. The first part is understandable now. Do you understand the reasons for promises now?
Yes, I do. I do understand that it's meant for
Okay.
non-blocking and for something that runs at interval.
No, not something that runs at it about like
That's events.
run in the background. Like you can wait for the result to come in later on. Like you don't have to get the results immediately,
Okay,
right?
okay.
Yes. So you can wait for like the function can take its time to run and then return back a result to you. Rather than when you write a regular function like the one we had here, it will execute and nothing else under can run, right? If I have another application running within this so let's say I have a Node.js application running now, and I have this function being called somewhere in my Node.js application. If another and this function is taking like maybe 2 hours to run, right, or 1 hour to run to calculate something, right, and somebody else trying to call my Node.js application, because this function is running, it has held up the call stack, so no other function can be put on the call stack because of this particular function. But if this function were to be like a promise or an asynchronous function, this function will be doing the stuff in the background. A new function can be added to the call stack without affecting or being blocked by this particular function. That's the whole purpose. Do you get now?
Yes, I do.
Okay. So we're now going to go again to see how we can write a promise function, right? So we have in TypeScript, this stuff I put here is just the return type. I'm returning back a promise and the promise will return like back a string. That's what this is for. So you can ignore this for now. Now to write a promise function, you return back the promise class, right? So for you to instantiate a class in JavaScript, you use this keyword called new, right? That means you are creating a new promise class, right? Now, I was talking about the fact that promises have resolve and reject, right? Resolve is to return back a success state. Reject is to return back a failure state, right? Now, I gave an example whereby we modify this function to have two parameters so that we can simulate both the success state and the rejected states, right? So yeah, I'm just simply saying that, oh, if I pass this rejected to be true, right, then return back, like simulate a failure state basically where I'm saying there's an error has occurred within my promise execution. And that is why when we run this function here, you can see that this catch, right? You can see this log here says I am rejected an error, right? So it showed that, oh, my promise returned back an error, right? And this is useful where maybe you're doing some checks to check that, oh, is there maybe some states, is there available, some values available. This is very useful. So you reject, so if at all maybe the condition is not true or something, you can then like return back an error using this reject keyword. So the function reject keyword, is it clear to you guys?
Yes.
Okay. Now, the next thing is, like I said, resolve keyword, right? So resolve keywords indicates a success state of my promise function or my promise that I created. So yeah, I'm just using like a standard JavaScript function or set timeout where after some few seconds, so this is just kind of designed to simulate something that happens in the background, or like I kind of just pause the execution and come back after some few seconds, right? And that's why I'm using this set timeout as an example. It could be anything else, right? I could be running like calling an API, I could be calling another promise or whatever. And it's only when that promise has finished running and returning back a result, that is when I then resolve this particular promise I'm creating, right? But I'm just using this set timeout as an example just to show something that happens, that continues to happen while my other code continues to run. Do you get now? So basically, the resolve will then return back what I want to return back as a success state. In this case, I'm just returning back I am done, right? Which is just a general string. So do you understand like resolve, like the resolve keyword or function now?
Yeah, but what is that MS? I'm seeing
So,
something
so this
MS.
so this set timeout. So we are passing in the number of seconds we want to time out for. So I'm just passing the parameters from here into this place.
Okay, so
Remember that
there's
our
a
function is dynamic. So this is our function, right? This is our promise function. It has two parameters. This ms for the number, and this rejected to just simulate whether I want to reject the promise or return back a success state, right? So this ms I are seeing here, because we want to set timeout, you need to indicate how many seconds you are timing out for. But I just made that a dynamic parameter in my function so that I can easily change this value and into timeout for whatever value I put in here. Exactly.
okay.
So this set timeout is also a function in like a library function in JavaScript. So if you look at the function signature, you can see that it takes in another function, right, which can be called. Then it takes in the number of seconds you want to time out for. Do you get now?
Yes.
Yeah. So you could, like I said, this I don't have to do this. I could call on that function. I could do some calculations, and then when my calculation is done, right, that is when I will then resolve the function, right? So let me show you an example so that you guys understand like the practicality of this. So let's say I want to. I'm not even going to use. So let's write a new function, right? A new promise. Like we're not going to use sleep again. So function. mm, do every calculation. So this function will do an every work, iteration. So so let's result is equal to 0. So we have this function, right? Is a do every work function. Now we'll come back here. Let's create a sample promise function. Okay, so let's don't let me make it complicated for you guys yet. Okay, so let's call this function now. Just do every work, right? So we'll have a result here. So we're going to call this do every work. So you can see I'm iterating. This is how many millions now? 1, 2. This is like 1 billion. So imagine looping over 1 billion records. That's like a lot of time, right? If I was to do this, like just call this function, right? Nothing else is going to execute in my application, right? But because I'm using a promise, this can be running in the background where my other application can keep processing stuff, right? So we'll see an example now. So this will then return the result back when it's done, right? So this is our sample promise. Sorry. So like I said, if you want to call a promise function, you say the function name, then you use, so when you click dots, right, then you have this then keyword, right, which then contains the results. And also as best practice, you can also catch any error that was thrown by the promise, right? So that's what we are doing here. So you can see that this my promise can keep running. We'll also run another function now just for you to show that. So I think we can use this our existing, let me look for an existing function that we can reuse. So um, this class coming to this very soon. Okay, so let's use our print number function. So we'll come here and call it now. So you can see this, then you can see this. So you will see that this will probably return back a result before this, right? You will see that shortly now. So let's run our code. Because I don't want to kind of, okay, let's just run into that stuff. No. So hold on. I want to, so that we can see that other stuff was logged. So let me just use an iteration of 10 for now. We'll come back. So can you see here that this our so let's log this so that you know this is when the result comes in. So we can easily see on the console log. So can you see that this is our hello function, this is our print number function. Return the results back before this our promise was done. Did you guys see that? Are you guys following?
Yes.
Okay. So you can see that our promise was executing in the background. Meanwhile, it didn't block this our next function from being called. And that's why you can see this result before this final result from the promise. So do you understand the reasons for promises now?
Yeah, yes, I do.
Okay, that's writing, right?
Yes, Brighton.
Samuel, what about you?
Samuel, I think he has network problem.
Oh, he's not here again. Oh, oh,
Just the two of us. Even TS.
oh, wow. Okay. That's, that's interesting. And wait, if TS dropped off, that means we won't be, this class not be recorded, right? Or is our recording still on?
Yeah, recording is on.
Okay, okay. So that's fine. Um, so this is a very this is actually one of the complex things to learn in JavaScript. But you guys need to understand the concept because you're going to use it a lot in writing your code. And you need to understand the reasons why, right? And that's why I should run this example for you where if this were to be a regular function, right, it will wait for all of this thing to be done before it calls this function, right? But with promises, it doesn't, like, you can see that you didn't have to wait. This print number did not have to wait for this to be done. Like once I call this, it just keeps educating the background. Meanwhile, it goes to the next thing to be called, which is this print number. So that's why you can see print number got a result before my final result from the promise then came in. So it's clear, right?
Yes.
Okay. Okay, cool. So yeah, this is one way of writing an asynchronous function, and this is what asynchronous function is all about, where you have the function running in the background, meanwhile you can continue executing other functions in your code, right? And this is just a very classic example. There's also another way to write, which is like the new way of writing asynchronous function. It kind of gives you less control, but it makes you to quickly write asynchronous functions that does stuff. So yeah, instead of using the this new returning like a new promise and all of that, we'll use the async keyword, right? So asyn c. So async function, right? So let's say sample async, right? Now inside this function, we can then say results equals to do every work. The same thing we have here. And then, so it's like a regular function, but the function is an async function, right? So we're not using resolve or reject or anything like that, right? We can write it the way we write a regular function. And if you over on this, you will see that it's returning back promise. Can you see? It's returning back a promise, right? So that's like the very interesting thing about using the async. So you can see it's a simpler syntax than using this, but it gives us less control because I have to wait for this to be done before I return my results and all of that. But it's basically like literally like the same thing, right? If I was to use the set timeout here now, um, sorry, I could also do the same thing, right? Where I set timeout. So instead of using resolve, I'll then do return I am done, right? So this will not even work because this set timeout cannot return back a function to like it returns back a void statement, right? So what I can do is probably have another variable here. Say let's r is an empty string, then r is equals to this, and then I can then return r back. But you know, unlike our promise, when we're writing our promise, you can see that it gives me more control. I can actually wait for the timeout to be done and resolve the response within the timeout. I don't have to do this arc that I did here where I have a variable outside. When this is done, I then assign it to the variable and then return the variable, right? Because in this case here now, what will happen is that this will actually return back an empty string because this function is going to execute like no, it's a timeout function, so it's executing in the background. So it won't wait for this function before it returns back a response. So let's see an example now. Um, let me comment this one's out. Um, so you can see that we can also use the then keyword, right? I will show you another way to get the result back from a promise and asynchronous function. But for now, let's just know that there's a then keyword to get the results back, right? So if we run this now, you see it returns back an empty string. Can you see empty? Right? Because this set timeout is running in the background. So you can see one of the use cases where it pays to use a promise as against using like an async function. Is it clear to you?
Well, yeah, somewhat, but maybe I will have to look at it again later.
No, that's why we're having these classes so that we can take this thing chunk by chunk, right? Because when we start writing like complex stuff, APIs and Node.js, if you don't understand how synchronous functions work, it's very difficult for you to write your APIs. So this is a very, very important part. So I don't mind taking my time to explain everything again. So just let me know which part do you understand, which part don't you understand.
I understand the promise, but this
Okay.
async it's not so clear, honestly.
Okay, so what part is not clear?
Like the difference, right? Where is you said the difference that like the async, you have to control. You have control over it in the case of the promise, but for async you don't have, right?
Okay.
And then
So because you are struggling with the differences, right?
yes,
Okay. So to explain the differences again, right? What I try to explain is that writing the async function gives us a way to write a promise in a very like in a cleaner syntax and also like a faster way to write it. But it gives us less control, right? And I give an example of how that can come about. So I give an example of this set timeout function, right? We first of all wrote this using like a regular promise syntax, right? And that gave us control to know when we return back a result, right? And which was when the timeout has elapsed. But we now use an example where we're just using the async function to create our promise. But you can see that here we have no control, right? Because this variable I'm setting would happen after like 1 second, right? But the function will have run like a regular function and return back a result before then. So I kind of have less control over that. So it's just a matter of regular promises give us control when we can return back results. Like we can wait as long as possible to return back a result, right? Unlike when I'm writing my promise using the async keyword, it will execute like a regular function and follow step by step. So if I have a step in between the execution step within the function that is doing something in the background, it will not wait for it to execute. If you just return the response back immediately. And that's why we saw this as an empty result rather than I am done. Do you get now?
okay, I do know, I do. So it's more of control. So like in the promise now, um, it could it doesn't have to like wait for the other. It doesn't run like a normal function. The other parts can run while waiting while
Exactly.
okay. But this sync it executes like a normal function from top to bottom. Then it gets to a
Exactly.
point, he waits for a response and then before he continues.
Exactly. Exactly. So if I had another, so take for example now, if I actually took out this code, right? So that brings us to the next way to wait for a result, right? So remember that I had this sample promise that returns back. So let's use the sleep function actually. So this is very easy to understand. So I had that sleep function which is returning back a promise, right? And this async function is also a promise. Now inside an async function, I can wait for the result of another promise, right? Which is what I want to do here now. So this will wait for the result of this promise by using this keyword called await, right? So this await keyword allows me to run this my promise function. It do whatever it wants to do, resolves at the time it wants to resolve. When it's done, it should then return a result, and I can then return the result. So it means that this my async function will not just like so I bypass this use case where in my function execution flow there's something happening in the background, but it's not waiting for it and it's returning back this particular response immediately. But I didn't move all of that logic now into a regular promise function. But within my main function, I'm just awaiting the result of that regular promise function, and then I'll return the result. So it means that this result will not return back until this promise has been resolved or this promise has run, right? So this await keyword is one way of awaiting the result of a promise, right? So it kind of ensures that, oh, until this promise returns back a result, I won't go to my next line of execution. Do you understand?
Yes.
Okay. So if you run this now, you will see that it returns back I am done results now, right? And that's because it waited for this my promise to do whatever it's doing, and then return back resolve a response, and then I can then return that response, right? So that's one of the beauties of writing asynchronous, like using this async. So I can write my regular promise that does handle like things that happen in the background and then return a result. Then my main async function can then await that regular promise, and when the result is available, I can then return the result back in my function call, and I can then call that main function like this. Any questions?
No.
Is Samuel back?
No, it has bad network, so
Okay.
I enjoy today.
Okay, no problem. So I think I'm going to increase that assignment. I'm going to add some new stuff to that assignment because I need you guys to understand promises very well. So the functions that I wrote in that assignment are mostly synchronous functions. I'm going to add like some new asynchronous functions there for you guys to write. So let's watch out for that. Um, so if you have any questions on promises again, please ask, or on asynchronous function, please ask. We're good, right?
Yes, for now, yes.
Okay, cool. So let's go back to our slide. So we're going to go into classes. So this is probably the last part to touch on because I don't want to overload you guys with a lot, right? So we're going to go to classes, right? Now, classes, I think you've probably heard about object-oriented programming before, right?
Yes, I have.
Okay. So object-oriented programming allows us to be able to have separation of logic, encapsulation of your code, right? Where you can have everything that does something in a particular place or in a particular file and export all of that or expose all of that to another file, right? Also, it makes your code to be much cleaner, basically, right? So rather than writing, so all we've been doing before as in procedural programming or functional programming, so writing a function, you execute line by line until it gets to the end, right? Or object-oriented programming, I can create like my class, right? It's all about classes. I can create my class, and when I need to invoke my class in the function, I can bring that in. So take for example what we did for these promises again, right? Where, sorry, is that my code base? So remember that this promise that we were writing initially, it was this promise here is a class actually, right? So it was actually a class. So the class available in JavaScript, right, by default. So it allows us, so you can see that we didn't have to rewrite all the procedures in how this class is executing. We're going to execute like my code or whatever. Someone has written it already. So I'm just putting that into my code and then be creating like a copy, so to say. And that's why we're using this new keyword, right? Which is like creating like a copy of the class, right? So object-oriented programming allows us to be able to do stuff like this, where you can have a class that you have written with all your fantastic methods and all of that, and someone else can just create a copy of that class and execute all the functions or execute the things that you've written in that class without necessarily like writing the entire execution end to end within his own code. So that's the whole essence of object-oriented programming, right? Where's our sorry? Where's our screen again? Yeah, so that's the whole essence of object-oriented programming, right? Now we're going to break down the architecture of a class, and this is also another very tricky or let's say complex stuff in JavaScript, right? I'm going to take my time as much as possible to explain. We'll probably even just today's class will probably just go over the initial part of this. Then the next class will go deeper into it, right? Because I really want you to understand this concept, right? So now, for a class, right, it will have a name. And for us to create a class in TypeScript or JavaScript, we have this keyword called class, right? So you remember that for us to create a function, the keyword was function. For us to create a class, the keyword is class, right? Then can you guess what this is?
That's a person is a class.
Yeah, so the name of the class, basically. Do you get now?
Yes, I do.
Okay. So how you create a class. So just assume that all this thing is not here. You just class person and this empty curly braces. You have a class, right? Now moving on, a class can have a constructor. Now a constructor in a class is what we use to initialize all the properties of that class, right? So take for example, let's use the TypeScript variant here, right? We have this property called name. We can have age. You can have. And let me go. This is the time I can go back to my code now. And let's use. Now I know you have been seeing that class stuff for a while now. So we're going to go. We're going to go into that now, right? So we have this class called person, right? So another thing again about a class is that apart from the constructor, a class can have properties, right? Properties are like just thinking about them as variables that hold a certain value. But right now, one major difference, I think you're probably seeing it here. For the properties of a class, what's the major difference within the way you write a regular variable and the properties within a class? Can you spot the major difference?
I think we don't use a let.
Yes, we don't use any of those variable initialization keywords. So let, constants, we don't use that. We can just write the name of the variable immediately and assign them a type or assign them a value, and we keep it moving. Do you understand now?
Yes, I do.
So these are all properties of the class. Now we also have also we'll come back to constructor because this is like a very tricky part to explain. I need to explain everything else. So we have these properties of the class, right? It can be anything at all. You can name your variable and everything. They will all belong to this class, right? Also, we have what we call methods of the class. So methods of the class are just functions that are available within the class, right? Now, methods within the class are also almost like properties because the same way you access this name, age, height, and the rest, the same way you access the methods by using the dot stuff that we were always using for objects, right? So remember an object as a data type, right? That we had initially when we are going through data type. So we can have like this object says person dot age, for example, right? And if I want to call a function, so I also have this, right? So the class properties and the class methods are all called or accessed the same way. There's no difference. Just that one is a function and another is just a variable holding a value, right? So another interesting thing about classes is that if you research on the data types object, an object kind of mirrors what a class looks like, right? Because if you look at this object here now, we have person, right? The object can have like various properties. I can also have methods, right? And I can call those methods and execute, right? But major difference you are seeing here within a regular object and a class is that I can't copy this object. For example, I can't create a new copy. Secondly, I can't initialize any of the values in this object using my constructor, right? So those are like some of the major differences between, because in JavaScript, you probably be seeing that this object is looking like a class. I can access properties. I can even have a function inside the object as a property, and I can call it. So what's that difference between the object and the class, right? And that's why I'm giving that difference, right? Where a class has a constructor, an object does not have, right? Also, I can create a copy of, easily create it, like insert like a new copy of a class with different values and different parameters, but an object, I can't do that, right? So these are like some of the major differences, but let's go back to our class, right? So you can see here that the class has methods, right? Then also there are what we call getter and setter methods, which are reserved methods in your class, right? Now, getter methods are the words initiate getter to retrieve the value of a property or within a class. So here you can see this getter method called getName. It's just returning back, and it always has to return back any of the values of the properties in a class, right? Then we have this setter, which as the name implies, to set the value, right? So it's basically like override the value of name that I have initially if I have any in the class, right? So I can have as many getter or setter methods as I want to. So, but they are strictly for modifying the value of properties in the class or for returning the value of properties in the class. They're not for doing any other thing apart from that. Um, is that clear? Hi, Brighton.
Yes, it's clear.
Okay. Okay. Cool. So then we move over to different types of methods in class. Now, there are what we call static methods, right? And there's what we call private methods and public methods. By default, every method you write in the class is public. So that means that when I create a copy of this class, this method will be available, right? When I use that, remember that new promise that we did, right? The reason why we're able to do new promise dot then, that then that we had here, this then that we had here is actually a method in the promise class, right? So the reason why we're able to call it because it's a public method in the promise class, right? Um, so and by default, any method you write in a class is public, right? Now we have what we call static methods, which are methods that people cannot override. Like you can't override that method. Because right now, if you inherit this, so there's something we call class inheritance, we'll talk about later in our next class, right? But if you inherit a class or create a copy of a new class, you can actually override how this a particular method within that class would work, right? And static methods, if you make your method to be static, it means that that method cannot be you cannot override that method, right? So that's the difference between public and static method. Now, private methods are methods that you cannot access outside the class, right? So if you try to say, oh, person.get PMI, it will never show it. You try an error that this function or method does not exist, right? So they're only used within the class. Those methods are only used within the class. You cannot use them outside the class, and they'll not be available outside the class. So it helps when you're writing like stuff around like security conscious stuff where you don't want to expose a functionality. So maybe you have a way you calculate or passwords, for example, right? You don't want to expose that method. You don't want to allow that method to be written. You can make that method become a private method within your class, right? Any questions so far?
No, no question.
Okay, so I just give an example of other types of method. I mean, you can also have an async method, and you can also have a regular promise method within the class, right? So these are like, this is like the anatomy of a class, right? So now I have this my class person that has this property. He has all these method types. Finally, now, what makes class dynamic is the constructor, right? So like I mentioned earlier, constructor allows us to be able to initiate or instantiate values of all the properties in the class. So take for example, by default, this my height and weight is 0, like I've set it within my class code. But if I also want to be able to override so change this value of height and weight, I will just add it to my constructor so that when they are calling my class, they can pass in their own value of height and weight, and I will then use that within wherever I'm referencing that height and weight within my class, right? So constructor allows people to initialize values or properties within my class. That's the whole essence of a constructor. Now, there's something about constructor which I'll not go into right now because we're not talking about class inheritance. But if this class was inheriting another class, right, then we have what we call the super keyword, right? So the super keyword we then call like that other class constructor with some values, right? So that I can have that class. So let's see if we can quickly show an example. I don't think I have any other class here. Okay, I have class citizen. Okay, yeah, so I think I have an example below here. So let's go back. Let's go to the citizen class. So you can see the citizen class is extending the person class. So it's inheriting all the properties and all the methods available in the person class, right? And here you can see this super keyword, right? Because this my person's class had name and age as what I was asking for in the constructor. I exposed the constructor. So when I'm calling the constructor of this citizen's class, I need to initialize, first of all, initialize the value of the person's class. And that is why I'm sending in John, and I'm also sending in the other value that is expected. And then I obviously assign the values within the citizen class and keep on with my code, right? So that's also another way, another thing that can be done in a constructor, right? If you're inheriting an existing class, you can call the super keyword to initialize that class you're inheriting from, right? And then you have everything available within the code, right? Any questions?
No question for me.
Are you so what are the various components of a class?
You made mention of constructor, and you also talk about like some kind of variables that are defined, that, but not only variables. You call them the attributes. And
Mhm,
then you made
mhm.
mention of objects. And you said object. The object is not like a class, but like when we want to instantiate the class, that's when we get the object. And then you made mention of getters and setters. Like they help us with I don't know, working with those attributes, those variables that you declared in your class. Then you talked about um, this keyword that be super keyword, that super that you. Okay, you said you won't go into that. You said this keyword will be maybe when we are trying to call something that is inside that class already, something like that. Then what else? Then the constructor you said is it's not really like a class per se, but say you only need it when you want to instantiate an object, something like that.
Yes, 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 yes. Okay, okay, okay. Cool, cool, cool. Um, yeah. So we'll go over this again in the next class, right? We'll see examples of how. So now I've written my functions, my methods in the class. I have the constructor. How can I like call the class? How can I run the methods in the class? What are the methods that are available for me to over? How can I override an existing method in the class? All of that, we'll discuss that in the next class.
All right, thank you very much.
But any question what we've done today. I know we've done like these are like some really thick part of the language. So we don't worry, we'll take our time to like as much as so that
Although
you can really understand.
the class aspect is not, because I'm a bit used to OOP, so
Oh, okay,
it's not really,
okay, great.
like the same. But is this promise that I think is a TypeScript specific kind of thing. Promise and asynchronous. That maybe I will really need to sit down and after this class and look at it.
No problem, no problem. Okay, no problem. Yeah, so that's it for today's class. Would discuss more. So like I said, for this problem stuff, I will add our for our assignments, right? I'll add the promise stuff to our assignment so that it's at least able to also get a hang of how to use promises, right? So
Okay,
yeah,
no
this
problem.
class we'll go over classes again. We'll see how to call classes methods, how to vary the methods, like I said, how to instantiate and all of that. Then we'll also go into TypeScript interface. So this is going to be very TypeScript specific. So interfaces in TypeScript, how do I create my TypeScript type and all of that. We'll go over that in our next class. But yeah, thank you very much. Hope you are getting ready for tomorrow's memorial.
Yeah. I know when I saw it that you are going to have a haircut, I just think so tomorrow.
Busted. No, wahala. Well, I just had to. You know, my wife
So
will kill me.
yeah. But by the way, it was even I know it was I've seen your face on Twitter once also. But I think I even followed it. That was how I knew, and I was able to pinpoint that, oh, this person is that brother. So hello.
Right. Sorry. Yeah. No.
What?
Sorry. My network went up very well.
Okay, I said it was you made mention of your wife. Like if you don't look good, like maybe your wife
Yeah, I don't
going
cut
to
my
kill.
ass. Yes, sir.
And I said it was
Yeah.
when you were sharing your skin that I saw you. But I know I follow you on Twitter before now, so like you and your wife. So even when the engagement happened, I was able to.
Yeah.
So when
Oh wow.
you were sharing your skin, and then I saw the wallpaper, like her face there. I said, "Ah, so is this person?" I know I follow you on Twitter
Ooh,
before now.
I didn't even know you for them. That's interesting. It's such a small word.
Yeah, really.
Oh, Allah. Make I go chop, go sleep.
It's all right. Good night.
Good night. Bye.